Hello, everyone, and welcome to the Altinity guest webinar entitled Adventures in Observability, How In-House ClickHouse Deployment Enabled Instana to Build a Better Monitoring for Users. My name is Robert Hodges. I'm CEO of Altinity. Just a little bit about myself as well as Altinity as a company. I've been working on databases since 1983, so almost getting on to 4 decades of work with databases of various kinds. ClickHouse is my current one. Altinity offers support and services for ClickHouse. We're the main enterprise provider worldwide, particularly focusing on United States and West European markets. We're also major committers to the ClickHouse project as well as the ecosystem projects like Grafana, and we're a major sponsor of community events worldwide. Today, it's my pleasure to introduce Marcel Birkner, as well as Yoann Buch, who will be doing the main presentation. I'd like to just give you a few little tips that will help you enjoy this presentation as we go forward. First of all, this presentation is recorded. We will be posting links to both slides as well as the presentation recording. Afterwards, you'll get these automatically in email since you signed up. Second, we have a question and answer box. If you have questions, feel free to post them in the box. It's labeled Q&A. We will either answer them in passing, depending on whether the presenters can feel that they're relevant, or we will have time at the end to answer them. And we'll also have some dialogue back and forth, exploring some of the aspects of the talk between us. Final thing, we'll run a short poll at the end of this webinar. This will take you 15 seconds to fill out. No more than, it's only 3 questions. We run these polls just to give us a little bit of feedback on how we did on this webinar and what we can do to make future webinars interesting and useful to you. With that, I'd like to turn it over to our guests from Instana, so please take it away.
Thank you, Robert. Thanks for having us. So my name is Yoann. Hi, everybody. A little bit about myself. So I work as a software engineer in Instana. I previously worked at Microsoft and then worked on the developer tool Find the Flow. And for the last 2 years, I've been happily using ClickHouse since I joined Instana.
Thanks, Yoann. Thanks, Robert, for having us. My name is Marcel Birkner. I'm a site reliability engineer at Instana and have about 10+ years experience with software engineering. And now for the last 2.5 years, I'm working at Instana and taking care of our SaaS platform. Yeah, so let's get started. And there's a lot of slides. So yeah, you heard already about the 2 companies. So Instana is an application performance monitoring tool. And we want to show you today how we utilize ClickHouse to drive our application and our SaaS platform. So what is Instana and where do we use ClickHouse? So we are monitoring application for, let's call it, dynamic applications. So just to give you a better understanding what that means. So our customers typically install an agent on their hosts in their system. The agent then has various sensors. We support a couple hundred technologies that we scan, auto-discover, like host, Docker containers, Kubernetes, different programming languages, applications. And then all the data is sent by the agent to either our SaaS platform, or if you use our product on-premise, the data is sent to your on-premise, the on-premise Instana installation. And we have 1-second metrics resolution and automatic tracing support. And why that is interesting will come later in this talk when we show some of the ClickHouse monitoring. So for the automatic tracing part, we support pretty much all the major programming languages like Java, Scala, Python, PHP, and .NET. Here, our agent automatically attaches to the applications and does the tracing part. With Node.js, Golang, Ruby, and Crystal, it's not as easy, but there you just need to include a library of ours, and then we can also trace these languages. So not a lot of people know what distributed tracing is. So just think of all these boxes on the right-hand side as different parts of your system, like you have a web application, and maybe a web shop, then a payment system or storage system, So user request comes in, then it goes through all these different systems of yours. So through different hosts, maybe even different data centers. And in the end, what distributed tracing is all about, on each of these boxes, or on most of them, you will have an agent running. And then in the end, you will get a distributed trace like this. So you get to see how long a certain call took, like opening a shop and doing a product search. You will see all the calls that go down all the way to a database, to a queue, to a different system, and do a drill down. So that's in very short words what distributed tracing is all about. And yeah, obviously you want to detect errors or maybe latency issues and want to see where most of the time is spent and why your web shop maybe is slow. And with our application or our monitoring solution, we also create a dynamic graph. So we know in which zone a host runs, what containers are running on there, and we monitor all the processes, JVMs, and maybe if there's an Elasticsearch cluster running, also the Elastic nodes. So if one host goes down, through this dynamic graph, we know, okay, there's an impact to this Elasticsearch cluster, and we can notify the operations team accordingly about the impact of maybe that host failure. And to do all that monitoring, we gather a lot of data. So we have a lot of metrics, events, and configuration catalogs that we collect through these agents. And we also store traces and end user monitoring data. And for these last two parts, which are very core to our monitoring solution, we use ClickHouse because it's just a really good fit for us. And we've been using ClickHouse now for 2 years in production. And you will see now what that will look like. So traces and end user monitoring beacons. That's where ClickHouse helps us. So all these traces that come in, we store them, we prepare them and store them in ClickHouse. And from that, we generate different dashboards in our application. So you can see, here's an example dashboard from one of our demo applications. And you see it processed 530,000 calls. And from these calls, it also generated the number of erroneous calls and just does a lot of, it just shows you a lot of variable information in very short time. And we also have like a dependency graph where you can see, okay, I have a distributed trace. The calls are going from one system to another. And if you look at the demo, the public one, then you see these boxes flying through these different services. And you can follow along. And if one has a problem, it impacts the others. Yeah, and to query and process all these calls, and for the user for it to be usable, on average, we have a mean latency of just 400 milliseconds in production. So the response time we have for all these queries that happen on these pages is just extremely fast with ClickHouse. So we are quite happy with that. So here's just the percentiles for the different distributions in this lower right chart. So it's a good fit for us. Yeah, and for the application data, all these calls, we can do various analytics. So we can do slicing and dicing, just look at certain endpoints, or drill down only and look at only certain technologies. And that all within just a few seconds, we go through hundreds of thousands or even millions of rows for the user and have almost instant feedback. A very low latency loading times of these dashboards. And then you can drill down and actually look at the call itself. And let's say there's a database call, and here on the right-hand side, you see the details and the SQL statements, the stack trace. And pretty much most of this dashboard comes directly from our ClickHouse data and comes up really fast. And we store all traces that we collect. So that's why we have billions of rows in our ClickHouse clusters. Yes, so that's what dashboards for end user monitoring would look like. Just a lot of calls and all this data you see here is generated from queries to ClickHouse. Yeah, so how do we operate ClickHouse in production? So we have one ClickHouse cluster per region, per SAAS region, and right now we operate 4 SAAS regions, 2 in US, 2 in EU, and we 2 of them are in AWS and 2 of them are in Google Cloud Platform. So we are multi-cloud, and yeah, setup doesn't really matter. So most of the time our clusters have 20 nodes. Some of them have R5 8x large instance nodes and instance types. Some of them have, 2 of them have M5 12x large nodes. It just that these instance types just depend on the type of customers we have there. If there's a lot of tracing data, if we need more CPU, and they all have 10 shards. So we have 10 shards and 2 replica per shard. And the replica are across AZ. So the replicas, so we always have a copy of the data in a different availability zone, just in case. I hope that never happens and AZ goes down in Google or in AWS. Yeah, and in general, up to a couple of weeks ago, we had 1 12 terabyte volume on each of these nodes, and the cluster was at roughly 180 terabytes, the largest one. And then we did some schema changes, so used some more compressions, and we got the cluster down to 70 terabytes. And we, in the same step, we switched to the JBOD feature, which just came out a couple months ago. So just a bunch of disks, and we're using now 2 smaller disks. It gives us a little bit more performance and gives us more freedom to grow in the future, because in AWS, maximum volume size is 16 terabytes, and yeah, we are growing fast. So only having 1 disk and then having to scale with more hosts, yeah, we also don't want to spend too much money. So this feature is quite came at the right time for us, I would say. Yeah, here are some stats. So we have received about 660,000 spans, so traces per second, and about 120,000 end user monitoring beacons on peak times. So that's usually like a business day. So at peak of 120,000. And that's about 10 terabyte ingress a day per region. So, and pretty much all of that goes directly through Kafka ingress pipeline to ClickHouse. And ClickHouse handles that load and the data pretty well. And that's our architecture. That's how we've decided to utilize ClickHouse. So in the front part, we have various tenant units, various customers that, and all of them have agents sending data in. So you can think about all these boxes as Kafka topics. And then we have various writer components. And so this one is shared. And I think we have 20 of them right now in production per region. And we decided on having a single writing component so we can batch all the ingress better. That's one lesson we learned. So at the beginning, we wrote too many things per second, like hundreds of times per second, and ClickHouse didn't like that. So so we changed that to be roughly 1 or handful of inserts per second. And the batches are just bigger, but ClickHouse handles that really well. On the other side, then in the middle, we have 10 shards, 2 replicas each, and a Zookeeper cluster with 3 nodes on the bottom. And on the right-hand side, for reading, we have a HA reading component, and yeah, that's also a single point for reading, so we can do some query throttling. So now the interesting part, how do we monitor ClickHouse? So since we are a monitoring company, we use Instana to monitor ClickHouse. So all these screenshots that you see here are from Instana. We do infrastructure monitoring, so we have 1 second metrics, host, CPU, memory, disk I/O, networking. Then we have ClickHouse, host, and cluster dashboards, where we can see merges, inserts, queries, and replication. For Zookeeper, we have dashboards, and their GC performance, I/O, suspension, and heap are interesting for us. So a lot of the JVM parameters and the reading and writing components. These are drop wizard apps in our case. So they're also Java, so JVM based applications. We have and yeah, we created for us a couple of SLOs or service level objectives and service level indicators that are also built into our into Instana. So we get alerted on problems with Zookeeper or replica read-only issues with ClickHouse. And here are some examples what these dashboards look like. So here you have the host metrics, then you have the ClickHouse service dashboards with upstream and downstream services. So you see who is writing and reading to ClickHouse and if there are errors. And then you have the ClickHouse host dashboards that show you queries. And then some cluster dashboards. So this is one of our clusters that has roughly 800 billion rows at the moment. And yeah, same for Zookeeper. So here's some screenshots on what the JVM metrics look like. So heap and suspension, host metrics and IO. Yeah, so that's from the operations side, what we do, or what we look at, or what we get paged on if there are problems with the application tracing part of the application, so where ClickHouse is used. And there's some lessons learned we had on the last 2 years. So at the beginning, we had one database per tenant unit, and that means roughly 10, 12 tables per tenant. So there were thousands of tables that we had to create and write to, and that didn't work out for us too well. So we had too many part problems. And that's when we learned that we need to keep the writes down to ClickHouse. They can be big. We can write huge chunks of data to ClickHouse, but the number of writes just need to be small. And I think somewhere I read 1 per second is best, and that's where we're trying to tune our configs to for our components. Yeah, and also running schema migrations for these thousands of tables was just getting too complicated and took too long. So we migrated everything to one shared database with just a handful, like 10 to 12 shared tables. And we have some materialized views as well. So let's just say it's 10. And then when we started out with to set up Zookeeper for the ClickHouse cluster, we thought, okay, we have a big Kafka cluster, so let's just do the same sizing as we have with the Kafka setup, but that just didn't work out too well. So that's how when we learned that ClickHouse just utilizes Zookeeper a lot more than Kafka does. In Kafka, it simply just stores the partitions and where they're located on which brokers, and that's pretty much all they use Zookeeper for. And for ClickHouse, Zookeeper is used for the queries, and the load is just higher. So we needed to increase CPU memory and also the disk I/O performance significantly. So, and once we figured that out, that problem was solved. Yeah, I talked about the disk limit we reached, we're approaching in AWS. So we switched to the JBoard feature. And if you're interested in how we did the live migrations to the JBoard feature, there's a blog from a colleague of mine that you can read up. That's pretty detailed and shows how we did that in production. Yeah, and the last thing I want to mention is we started out with following the ClickHouse GitHub release pages, but now for the last 1 year, we follow the Altinity blog, and every time they release a new stable version that they announce stable, we usually try to upgrade our clusters like within a couple of weeks afterwards, because we are using quite a lot of the latest features. So we try to stay as up to date as possible. Okay, so that's it from my side.
Great, thank you, Marcel. So we've talked about how we operate ClickHouse. We also talked about how we use Instana to monitor our ClickHouse clusters at the infrastructure level. Now I'd like to talk about ClickHouse monitoring in the perspective of engineering. So at Instana, the developers are in charge of creating and maintaining the schemas, and also, of course, writing the services and queries against ClickHouse. If you can just backtrack one slide before, please. And so, yeah, and to us, ClickHouse monitoring really boils down to query performance. And that means as a developer, we use Instana to detect the failed and slow queries, and also get a better understanding of where they come from. Yep, next. So typical use case for developers is to detect the query failures. And so for that, we use Instana. And the nice thing about Instana is that it's going to automatically create services, dashboards for all of your services in your distributed system, and that includes databases. So here on the screen, you see a dashboard representing our ClickHouse cluster. All the data you see in the dashboard is coming from tracing data. And there you'll find the typical metrics that Marcel talked about, so call counts, error counts, latencies. You also see some top statements, and of course also links to infrastructure issues happening. So coming back to our example where we are looking for errors, we can take a look at this error rate chart and pretty much select a time frame where we see a high number of errors. And from there, we can drill down to take a deeper look at what happened during this time frame. Next. Yep, and so from there, you can jump to what we call the unbounded analytics. That's a place where you can slice and dice all of your calls, in that case, queries to ClickHouse, by a bunch of tags, properties, call properties. And there we're really focusing on so queries to ClickHouse and the ones that are in error. And as Marcel mentioned, there is no sampling. Instana captures all of your queries. So, and then from there you can select one of these query in error and jump to what we call the trace view. In the next slide, yeah. So here's a trace view, and on the right part, you'll have more information about the query to ClickHouse. So you'll know, for example, where it comes from, in that case, the app data reader service. You'll also know about the SQL statement and the error message. So given that information, you should have some pretty good hint about why your query failed. And so you probably have a good idea of how you could fix it. But now I guess it's where should you apply that fix? As a developer, well, if you want to fix a query, you need to find that query where you build it in your code. And so you need to first figure out what service, what part of the code is responsible for sending that query. And for that, we do have the trace. So on the left part, you see the query to ClickHouse in the context of the trace. And so you know what triggered the trace. Maybe it's coming from a website request, a request from a website. And then you can see all the services that got traversed by that trace down to the last service, which is making the call to ClickHouse. In that case, the last service making the call to ClickHouse is the app data reader service, and more specifically from the get service label endpoint. So then as a developer, it's pretty easy. You can go back to the code and apply the fix to your failed query. All right, next. So another typical use case for developers is to detect slow queries. So for that, you can, again, start from the dashboards that Instana offers. For example, you've got the latency chart over time, where you see percentiles. And we can also have the distribution also of the latencies. You can also start from the top statements, which show you what statements take the longest to respond. And from there, you can jump to analytics, so unbound analytics, where you can slice and dice your slow calls even further, so you can find some patterns. And the idea here is to sort of group your queries to ClickHouse in such a way that you pinpoint groups of calls which are slower than others. In the example on the right, we grouped the queries based on the API entry points. And then we sorted the results by latency. And so here it gives you a fine-grained level to figure out what is slow and what you should fix first, right? The get goals API entry point is the one that is putting the most load in ClickHouse. And of course, if we are able to optimize those, the queries coming from this endpoint, that would be a huge gain. Once you're at that level, then you can again jump to the trace view. First on the left side, you're still in unbound analytics, and you can look at your individual calls, slow calls in that case. You can pick one of them to figure out what's happening. And then you are back to the trace view. And so in the trace view, you'll be able to find, again, the SQL statement, some timing information, and the trace, which will give you context for your query. And again, since you have the SQL statement, you might already have an idea of why your query is slow. You also know where your query comes from, so you would be able to know where to fix the query. And also, as we'll see in the next slide, Instana will give you even more visibility into what's happening inside the ClickHouse cluster. So it's a new feature we're pretty excited about. It's about bringing tracing inside the ClickHouse cluster. What does it mean? It means that the traces that you'll see in Instana will not only include all of the calls through your services done to ClickHouse, but also the queries that are distributed over the ClickHouse shards. So on the screenshot on the left, what you see is that there is first a call to ClickHouse, which is going to what we call a coordinating node. And then this request, this query, gets fanned out across the other shards because the request, well, the query was done on a distributed table. And so you have a full visibility into how the SQL query that you created is behaving on the cluster. And this example is interesting because you see that, well, the latency as seen from the color from the outside is about 4 seconds. And surprisingly, for 3 of the shards, they were able to answer that query in about 2 seconds, while 2 other shards answered it in about 4 seconds. And so as we can see, of course, a query in the end is as fast as the slowest shard. So from there, you could either take a closer look at the SQL statement to figure out why it's that slow. You could also investigate a little bit further why some specific shards are slower. And for that, it would be pretty easy to jump to the infrastructure side of things to look at maybe the host metrics or the ClickHouse metrics to get a better understanding of why these 2 specific shards were slower than others. On the right part, for each of these internal query, you can see the SQL statement, and you also have access to the query, the settings that are applied to the query themselves. So in ClickHouse, you have global settings that apply for the whole cluster, but you can also override these settings as you query ClickHouse. And here we'll also tell you the settings that got applied. And again, that could also explain why something got slower. For example, if you change the number of maximum threads for that query. Yeah, I think that's it for that one. So some lessons learned from the engineering side. The system tables that ClickHouse provides are great for understanding how ClickHouse works. It's great to monitor how things are going. What I would recommend is that to enable the writing to the query log and part log tables. It's disabled by default, but the data that is in those tables is so valuable that we should enable writing to it, especially because it doesn't take up much storage. Of course, you can query the system tables, but then I think it's even better if you can graph those metrics over time, like we do in Instana, so that you can catch some patterns over time. And even better if you can also build alerting on top of those metrics so that you don't have to keep constantly look at your dashboards. Another lesson was that context is key. It's really important to know where your ClickHouse queries come from because there's ClickHouse, but then there is a lot of things revolving around your ClickHouse. There could be many services, so you need to pinpoint which service out of many is making those requests. It's also interesting to see if that query to ClickHouse is originating from a website or a mobile app. And of course, if you're running a multi-tenant platform, it's interesting to know if what tenant made that request, or even at a finer grain level, what user made that request. And I'm saying that because a hard lesson for us was that a handful of tenants or users can easily eat up most of your resources. And thanks to Instana, it was rather easy to pinpoint and figure out what tenants were misbehaving, and then it was then easy to put some capacity management solutions in place to take back control, I guess. Finally, I think using a monitoring solution like Instana was great because it helps us really improve the performance of our queries by continuously monitoring performance. And what I like about it is that with Instana, it gives you some sort of a baseline where you know how well your queries behave. And then from there, you can quickly identify things you could improve. And once you have identified some queries that you should improve, then you can find the most appropriate solution for that. So you could optimize your query, you could add more shards, you could maybe query a materialized view or use some skipping indices. And for all of these improvements, then once you've implemented them, you can use Instana to make sure that it actually improve the situation. Yeah, and that's it. The next slide. So wrapping up, so some takeaways. So to us, ClickHouse is a reliable, scalable, and performant column-based data store. And I would add that it's a very developer-friendly database to use. It's really fun to use, especially because it's SQL. Also, it's really performant and it's still amazing us. And we are pretty happy users. The takeaway is that having such good monitoring in place really helped us with the steep learning curve that you get once you introduce a new database in your landscape, especially since none of us had prior knowledge of ClickHouse in the engineering or an SRE team. And having this monitoring in place, I think sped up the process. It helped us to quickly understand how things worked, and also I think increase the feedback loop with more trial and errors. And finally, I would say that the big takeaway is that the infrastructure monitoring by itself is not sufficient, at least not for us. There's of course, the infrastructure monitoring is really important, but there is also a lot of things that you should think about that revolves around your ClickHouse cluster, and that is your services, your websites, your users. And that is the context that distributed tracing gives us. And it's really important because it gives us end-to-end visibility and an easy way to pinpoint where the issues come from. So for all of the screenshots that you've seen throughout this presentation, they come from Instana, an Instana user interface. Of course, if you want to have something more lively, you can go to our demo public environment. It's play-with.instana.io, and there you'll be able to play with Instana with a sample application. Also, if you want to try out Instana on your ClickHouse clusters, you can do that, and you can go to instana.com and sign up for a free 14-day trial. And there you'll hopefully be able to see your ClickHouse cluster appear on the map and start playing with all those dashboards and alerting. And that's it from my side. Do you have anything to add, maybe, Marcel?
No, not at the moment. I'm just looking at the questions and I'm trying to answer them right now.
Great. Yeah. Hey, this is Robert jumping back in. Thank you so much for this talk. This was completely awesome. What I'm going to do right now is, since we're at the end, I'm going to go ahead and launch our poll. And I'd like to invite everybody on the call to go ahead and fill that out. It helps us, take you 15 seconds, helps us make these webinars better. Before we jump into the user questions, and I'm glad to say we have lots of time to go into them, they look interesting. I had a quick general question, which is that you're operating a very big service, and ClickHouse is not the only database out there. You said you introduced it a couple of years ago, but I know you're also running things like Elastic, Cassandra, other databases as well. Can you comment a little bit about the different databases you have and what you see as the trade-offs for different use cases of ClickHouse versus, say, Elastic versus Cassandra or any other databases that come to mind?
Yeah, I guess I can start on that because there's also one question regarding, I think somebody mentioned, yeah, regarding that, also about infrastructure metrics, why we don't store them in ClickHouse. So at the beginning, roughly like before we used ClickHouse for storing the traces, we used Elastic. ClickHouse is a column-oriented data store. So you know the types that you want to query on. Elastic is a documented based one. So we couldn't offer the slicing and dicing analytics functionality with Elastic. Like what Elastic is good for, and we still use Elastic for one other part of our product, to find documents, like unstructured documents, and then have unstructured data in there, and then just display these results. But doing the analytics part, like calculating averages, total counts, means, and so on, that just was not possible with Elastic. And I think it's also not the right, like it turned out not to be the right solution for us back then. That's why the feature set was much smaller than what we have right now. But Elastic is a good data store, but just for different workload, I would say. Like we definitely couldn't do tens of millions of rows processing in a few seconds with it. And with ClickHouse, that's not a problem at all. Regarding the question why we don't store infrastructure metrics in ClickHouse, we use Cassandra for that. Because we calculate rollups. So our metrics, we have like 1 second resolution, 5 second, 1 minute, 1 hour, so different rollups. And there, Cassandra is just a much better fit doing these rollups, having a time window compaction strategy. So that just works better for us. Yeah, but for the analytics part, yeah, it's just 100% ClickHouse for us. I hope that answers the question, Robert.
Yeah, that's a great answer, and exactly the kind of trade-off that that I was interested in. I mean, we kind of see the world as, very much having very polymorphic, with different data stores for different use cases, and it definitely seems that that matches your experience. So I have another question for you at the end, but if you want to dive in and just answer some of the user questions or the audience questions, that'd be great. They look really interesting.
Yep, I can take one. There was one from Prashant who's asking if our tables are wide, how many dimensions in facts per table, and how it's affecting, I assume, writing and reading performance. So yeah, like we said, there are about, we do have about 10 tables. Regarding the traces, we mainly have a single table. And this table is pretty wide at the moment. It has over 400 columns, and we keep adding more. So far, I mean, it hasn't been a problem, especially, well, because ClickHouse is a column-based data store, and so the query performance is really directly related to how many columns you want to read. And so for each of our queries, we usually just select a handful of these columns. And again, for a given trace, we don't, of course, store values in all of these columns. So we get a lot of empty columns for each row. And regarding writing performance, of course, the more, I guess, columns you have, the more likely you have data, and the bigger your inserts are. And so the longer they will probably take to be ingested into ClickHouse. I hope that answered the question.
Yeah, there was another question about the delay for the traces. So from the, I guess that's from the time we gather the trace on the agent side. So let's say in your data center, all the way to when it's written to ClickHouse and then readable in our visible in our UI. For the traces, I would assume that somewhere between 5 to 10 seconds on average. But I don't have 100% precise numbers on that. For the metrics that we store in Cassandra, I know it's somewhere between 2 to 3 seconds. For the 1 second metrics, so there's like a 2 or 3 second delay from the time like it gets all the way to our data center and then is stored in Cassandra and shown.
Yeah, I can add on to that. For a main table, well, first of all, the delay, the first delay is happening in our writers. So the component that is batching our data before inserting to ClickHouse. And of course, batching means there is some slight delay, and at most it will take a few seconds. And then since the inserts are pretty large, it can take about between 10 to 20 seconds to get fully inserted into ClickHouse. But that really depends on the table and how much data there is to insert. But then once it's in ClickHouse, it's available right away through our UI.
So Marcel, looks like you have one from Yuri.
Which one?
Can you elaborate on how you store spans in CH, one per row and Y10 tables?
Yes, so what we do is we extract a couple hundred, I think it's roughly 400 data points or information points. What do you call them, Yoann?
Tags, yeah.
Tags, yeah, roughly and those tags we store then in ClickHouse. And the full trace or the full span we store in pretty much S3 because like the full-blown JSON with all the tracing detail. So in production and SAAS, it's stored in S3. And then only if somebody wants to look at that one and wants to look at the full trace thread from there. But to do all the slicing and dicing on these growing list of labels or tags, it's 400, roughly 400 right now. That's what we store then in ClickHouse directly.
Right. And so if you take a look at a trace, so a trace, what is it? It's a set of spans, or what we call here in the Instana, it's calls, right? One call between two services. And so each row of that table corresponds to a given call or a span. And there you have those 400 tags or columns, if you will. And we pretty much build all of our dashboards from these tables. And that's also how we are able to provide this unbounded analytics feature where you can slice and dice the traces by on the high cardinality. And why 10 tables? Well, we pretty much have one table for the traces, one table for beacons, and then usually and a few other companion tables. But then we, of course, with ClickHouse, you've got a lot of table engines, and then for every, let's say, replicated merge tree table, you have a distributed table. We also do use materialized views, so then we have a couple of those, but they do all represent pretty much the same data.
In fact, you've got a question, I think that might be a good segue. There's a question, how did ClickHouse's aggregating merge tree compare to Cassandra rollups for pre-aggregations, if you have insight on that?
I don't think we've evaluated or compared these two for us. So when we revamped the part of the product, which we call application perspectives, where we display all these dashboards coming from tracing data, one of our requirements was really this ability to slice and dice data by everything, and having Cassandra and doing some pre-aggregation before at right time was a no-go. We really wanted to have all the individual spans or calls, pieces of data in ClickHouse, so that only later at read time we would do the aggregation. So I don't think that's something we've evaluated so far.
Great. And I think we got the what tables did you use to identify time spent? That was the query log. So I think we got that one. I had a follow-up, like a follow-up question, since I don't see more user questions coming in. And that is, what would you like to see next in ClickHouse? It sounds like it's been really successful so far. You've used, like I was really happy to see that you're using JBOD, which is something we spent a bunch of time on both last year and this year. But what do you want to see next? What would be important feature improvements for ClickHouse that would make it even better for your use cases?
That's a good question. So first of all, we're trying to catch up on all the new exciting features that is delivered by the ClickHouse committers. And for example, I'm thinking about, of course, the JBOD, but also we start using the skipping indices. We start using the low cardinality codex. But then as far as new features, at least for us, I would say that some sort of a resource management built inside ClickHouse would be really useful. I think it's especially when you run a multi-tenant solution like we do, it's pretty hard to fairly distribute the workload across our tenants. Of course, you can build that from the outside, but I think a little bit of help from ClickHouse would be appreciated.
Is it, Marcel, would you agree with that one, or do you have others that you're interested in?
Yeah, that one would be a nice one, but engineers, they can always build something around that to manage that themselves.
Right.
So they're lazy. So what we actually evaluated and just installed in our test environments last week was, or 2 weeks ago now, we are using the ClickHouse operator now, and we're evaluating if we also want to use that in production, because we have also we are also an on-premise product, so a lot of customers then would have to manage, or currently have to manage ClickHouse themselves, kind of, and the operator seems to make that much nicer, much easier. So, and but we're just, yeah, it's running now for 2 weeks in our test environments, and so that's the latest one that I'm using. So, and so far I don't have feature wishes there. It seems to be just right for our use case. So now we just need to gain some experience with it, like in case something does break, and how to fix issues. So, but we're always creating issues or tickets on GitHub if we run into problems, or we also had calls with you guys from Altinity in the past. So
right,
yeah.
So
if you have something, we'll reach out to you.
Excellent. Yeah, and I think for coming on and doing this presentation, you're definitely good for free bug fixes. just let us know. I want to comment a little bit on the resource management and multi-tenancy, because that's been a really hot topic, and I am sorry to say I don't have a deadline for when resource management is going to show up. That's something that there isn't. The last I looked, there isn't even a PR for it right now, and I think there has been some work to make pipelines more efficient in ClickHouse. There's a new model that was recently introduced. A lot of that work was done by Nikolai Kochetov. So that has consumed a lot of the resources that are available to work on the execution model. What we are focused on, and will be available in over the course of this year, are 3 important security-related features that help with multi-tenancy. One is LDAP integration, which you may be aware that is coming. I don't know if that's relevant for you, but the idea being that instead of having ClickHouse users being in a file, you can stick them in an LDAP server, and so you centralize it. This is very helpful for multi-tenancy. A second thing that's coming is role-based access control. So giving you the ability to actually have policies which will block, you know, now that you can put your users in LDAP, you can also then block them from seeing tables and columns that they should not see. So that's on the way, and is actually, we have a team of folks testing the daylights out of that this summer. And then a final issue is we're beginning to explore encryption functions. So we have a PR out right now for AES encryption. The model that we're working with is pretty similar to the AES encryption functions that you see in MySQL, if you're familiar with those. But again, that's beginning to edge into a feature that will give you the ability to, for example, encrypt sensitive data for each tenant with their own key. I anticipate that will be out in a production. That's a fairly, focused bit of work. I think that this will be out in an Altinity stable release in a couple months. So that's coming as well. So there's definitely a huge amount of interest in multi-tenancy. I personally, from what I've seen, and from working with many other databases, this just seems like a place where there's a lot of good features to add, and sort of across the board, both security as well as resource management, as well as being able to monitor what those tenants are up to. So we'll definitely keep in touch and let you know as we get more visibility on the resource management.
That sounds great.
Good. Well, with that, I'd like to thank you again. I believe we have answered all of our questions. You've answered the questions that I asked. Thank you so much. It was just a real pleasure to learn about Instana. Looking forward to collaborating with Instana and with your team, and thank you so much for this presentation.
Thanks for having us, Robert.
Yeah,
great.
Thanks a lot.
And thanks to the audience. Hope you enjoyed it. You'll see the links coming out within the next 24 hours. Thanks, and have a great day. Bye-bye.
Bye-bye.
Bye.